So first topic is significant figures. All right, clip numbers there as well for maths watch if you need to watch any further. All right, so it says round each of the following numbers to one significant figure. So you need to remember one significant figure is after the first digit, as long as that first digit is not a zero. So the first significant figure in a number is the first number that's not a zero, basically. Okay, and then after that, your usual rules of rounding will apply. So for question A, the first digit that's not a zero is 5, so we round after the 5. Okay, and then normal rules for rounding. So that number that I've underlined there, the 7, if that is 5 or bigger, we round up, and if it's less than 5, we round down. Obviously, in this case, the 7 is bigger than 5, so this 5 will go up to a 6. Okay, and the slight difference then when doing significant figures is any gaps that you've got left then. Basically, after I've drawn a line, there are 2 digits here, the 7 and the 8. Okay, you just replace those 2 digits with 2 zeros. Okay, so 578 to one significant figure is 600. Okay, so same thing then for question B. First significant figure is the first 8, so I'm going to round it after the first 8. Okay, so this second 8 here is bigger than 5, so the first 8 is going to go up to a 9. All right, and then when we fill the gaps in with zeros, we only need to do it until we get to a decimal point. So in the first one, really the decimal point is there. Okay, so we've just filled these 2 in as zeros and nothing afterwards. So when we do this one, it's only this 8 that we need to change to a 0, because then we get the decimal point up. So it doesn't make it wrong if you write 90.0 really, but there's no point in having the 0.0 on the end. All right, I could put a point and then 20 zeros and it'd still be the number 90 anyway. Okay, so that one's just 90. And then for question C, this time the first digit is not significant because the first digit's a 0. So the first significant figure in question C is the 6. So we should be rounding after the 6. Okay, and then same rules apply. The 8 is bigger than 5, so the 6 goes up to a 7. Okay, but that doesn't mean that the answer is 7. You can't ignore the 0 point in front. Okay, so the 0 stays the same, the point stays where it is, but the 6 rounds up to the 7. Okay, and then because we've already passed the decimal point, then there's no need to fill the 8, the 3, or the 1 in with zeros either, because the same as I mentioned in question B, if you write 0.7 or 0.7000, they mean the same thing. So there's no need to put the 0 on the end there. Okay. So that's the first set. So moving on now to 2 significant figures. All right, so you'll find the first significant figure in the same way that we just did with A, B, and C, and you round after the next number. So in question D, the first significant figure is the 4, meaning the second one's the 3, so we round after the 3. Okay, the 7 is bigger than 5, so the 3 will round up to a 4. Okay, and remember, it's only these 2 that are really we're looking at in there. The first 4 doesn't get affected, and then replace the 7 with a 0. So question E, the first significant figure is the 1, the second is the 6, so we round after the 6. The 7 now means the 6 rounds up, so the 1 stays the same, the 6 rounds up to a 7, and you replace the 3 other digits with zeros. And then for question F, first significant figure is the 6, the second is the 9, so we round after the 9. Okay, the 2 this time means we round down, which means the 9 stays the same. Okay, so 6, 9, 0, 0, 0, 0. All right, so 440, 17,000, and 690,000. And just a point to make on question F, right, when we round down, the number doesn't get smaller. Okay, so the 9 doesn't go down to an 8. When we round down, the number stays the same. Okay, so moving on. This leads us on to estimation then. All right, so to be able to estimate the answers to problems, we should really be rounding all of the numbers to one significant figure, so making them as easy as possible, and then doing the answer afterwards. Okay, so it clearly says estimate in these questions. So I know that probably everyone watching this could work out 6.8 times 312 if they really wanted to, okay, by using the box method and whatever, but this is not what the question's asking us for. Okay, so we're going to round 6.8, one significant figure. All right, so after the 6, the 8 means the 6 goes up to a 7, so 6.8 becomes 7. Okay, then 312 we do in the same way. So 3 is the first significant figure, round it after the 3, will become 300. So just remember, when it says estimate, we need to round to one significant figure. Now we can just work that out, it's much easier. Yeah, 7 times 300 is 7 times 3, 2 zeros on the end. Okay, and it doesn't really matter at the moment how far away this answer is from the actual answer, because it's just an estimate anyway. All right, and some of the questions can look confusing for estimating, but once you make the numbers easier, it's not as bad as it first looks. So this one looks a little bit harder, but it's easily done. So 3.7, round it from there, one significant figure, that would become 4. 8.12, one significant figure would become 8. And then 2.2 to one significant figure would become 2. And straight away, that's much easier now. So 4 plus 8 is 12. 2 stays on the bottom. And just remember then, this fraction line that I've just drawn means divide, isn't it? So 12 over 2 means 12 divided by 2. So the answer is 6. And we move on. Same with this one then. So we're rounding each one to one significant figure. So 5.2 will become 5. 3.7 will become 4, because the 7 means the 3 goes up. And 0.47, okay, the 0 is not significant, remember, so we should be rounding after the 4. Yeah, the 7 is bigger than 5, so the 4 will go up to a 5, so that would be 0.5. Okay, so 5 times by 4 is 20, and then divided by 0.5. And we've learned a long method of in lessons of dividing by a decimal, but with something like 0.5 is actually a much quicker way of doing it. So whenever you divide by 0.5, that's the same as doubling an answer. Okay, so doubling an answer is the same as dividing by 0.5. So 20 divided by 0.5 is the same as me saying what's 20 times 2, okay, which is 40. All right, so think about it this way. 0.5 goes into 1 twice, doesn't it? So it's going to go into 20 twice as many times. So that's why it's 20 times 2. All right, so dividing by 0.5 is the same as doubling the answer. All right, and then a worded question. These are quite common in tests. So a school sells 187 tickets for a school play. Each ticket costs $2.99. Calculate an estimate for the total amount of money the school made. Okay, so if we wanted the exact amount, we would do 187 times by £2.99. Okay, because one ticket costs £2.99, they sell 187 of them. Okay, we're going to estimate them. We're going to round the numbers to one significant figure. So this will become 200, because the 8 means that goes up. £2.99, we round from there, will become £3. So that's a simple fraction now, isn't it? 2 times 3 is 6. After zeros. Right, so an estimate for the money they made is £600. Okay, dividing decimals now. So the first two, you'll notice, we're dividing by a whole number. Okay, so it's a decimal divided by a whole number. So when this happens, all we do is do the bus stop method. All right, the number we're dividing by goes on the outside, 36.5 on the inside, and line the decimal up in the same place above as well. Then if you're unsure about your 5 times table, list them down the side of your page, take your time, remember to do each number separately. So 5 doesn't go into 3, okay, so carry the 3 over now because we haven't used it yet. Then 5 into 36 goes 7 times, okay, with a remainder of 1, because 5 times 7 is 35, we wanted 36. So we carry the remainder over to 15, and then 5 goes into 15. 3 times exactly, with no remainder. So the answer is 7.3. Okay, and then for question B, exactly the same thing. So 4 on the outside, because that's what we're dividing by. 47.36 on the inside, line the decimal points up, and then do the same thing. So 4 goes into 4 once, with no remainder. 4 goes into 7 once, with a remainder of 3. Okay, 4 goes into 33 8 times, with a remainder of 1, because 4 times 8 is 32, so a remainder of 1 to make 33. Then 4 goes into 16 4 times exactly, there's no remainder, so the answer is 11.84. All right. So if you're dividing a decimal by a whole number, just put it in the bus stop method straight away and work your way through it. So you'll notice now with question C, it's a whole number divided by a decimal, all right? So the way we learned this one in class was to write it out as a fraction first, okay? Because remember, we've already discussed in this video, the fraction line means divide, isn't it? So 24 divided by 0.3 is the same as writing 24 over 0.3. And then we do an equivalent fraction. We've just learned that we know how to divide by a whole number. So if we could make this into a whole number by timesing it by something, we can do the same on the top, and then it makes it a little bit easier for us then. So if I wanted to change 0.3 into a whole number, so into 3 instead, I would times by 10, all right? And then the reason we set it out as a fraction is to remember that if we're timesing the bottom by 10, we have to do the same on the top as well, okay? We can't just write 24 over 3, because that wouldn't make it equivalent, okay? So we've times top and bottom by the same number, we've made an equivalent fraction. So 24 over 0.3 is the same as, because it's equal to, it's equivalent to 240 over 3. And now we can work that out, okay? Because this fraction line means divide, isn't it? So 240 divided by 3. The bus stop method won't really help you with this one, okay? But work out how many 3s are in 24, which is 8, put a 0 on the end, all right? And there's no need to change your answer then, because lots of people get confused with this and think that we have to now divide by 10 or divide by 100. We've already made it fair by doing times 10 on the top and the bottom. So 24 divided by 0.3 is 80, because 240 divided by 3 is 80. And they mean the same thing, don't they? Okay, right, on to exchange rates then. So we spent a couple of lessons on exchange rates. So using a calculator and without a calculator as well. I'm just going to use a calculator for this. Just quickly get my calculator right. So current rate of exchange for British pounds to euros at Asda Money is £1 equals 1.137 euros. Calculate how many euros you would get for £450. So what we did in class is whatever the exchange rate was that we were given, we wrote that out. Okay, and then it should be obvious using this little diagram that to go from pounds to euros, in this case, you times by 1.137. And if we wanted to go from euros back to pounds, we would divide by 1.137. So in this question, it says, how many euros would you get for £450? So we're changing pounds into euros. All right, so it's as simple as doing 450, because that's what we're exchanging, times by 1.137, because that's what the exchange rate is. So just typing that in. And it is 511.65. Okay, and that's in euros. And that came out as 2 decimal places in my calculator anyway. Just remember, sometimes it might not. You may have to round it. Yeah, money is always going to be 2 decimal places in this one. If it doesn't come out as 2 decimal places, then you round it. All right, I'm just going to stop this. So it says, same information about the exchange rate. This time, question B is convert 828 euros back into British pounds using the above exchange rate. So we already wrote down, didn't we, that we would be timesing here by 1.137 or dividing. So in this question, we're converting from euros back into British pounds. So in your calculators, 828 divided by 1.137. Okay, so I'm just going to type that in. Divide by 1.137 equals. So this time I'm going to write the whole thing out just to explain what I was talking about at the end of the last video. So this is what comes out in my calculator, but obviously that can't be the answer in pounds and pence, because it makes no sense. So we've got to make sure for this one that we round it to 2 decimal places. Okay, so in this case, the 2 means the 3 stays the same. So in pounds, it would be £728.23. Okay. Okay, next one then. Still the same exchange rate. It says Mr. Gregory wants to exchange £450 into euros for his holiday. All right, but in Asda Money, and this is applicable to real life, sometimes we don't have the exact money that you want in terms of coins or notes or whatever. So Asda Money can only give the euros in 10 euro notes. Sorry. Okay, so how many euros can Mr. Gregory get and how much would it cost him in pounds? All right, so first of all, he's starting with £450 and he's changing it into euros using the same exchange rate that we've been doing. Okay, so if I type that into my calculator first of all, 450 times by 1.137, all right, that is 511.65. So 511 euros and 65 cents. But they've only got £10 notes or €10 notes. So we're going to keep doing that. They've only got €10 notes, so we can't actually get the exact amount of 511.65. Okay, the closest he would be able to get would be 510, wouldn't it? Okay, so he can't get that extra 1.65. So he can only get 510 euros. Okay, that's not the end of the question though. We've worked out the first part, how many euros can he get, but it also says how much will it cost him in pounds, because he's not going to give them the whole £450 if he's only going to get 510 euros. Okay, so now we're going to change that 510 that he can get back into pounds by dividing this time by the exchange rate, and then that's how much it's going to cost him in pounds. So 511.65, sorry, 510 divided by 1.137 is, I'll write the whole thing out again and then round it to show you. So it comes out in the calculator as 448.54881. Okay, which again doesn't really make sense. We're rounding it, aren't we? Okay, so from there, 2 decimal places, the 8 means the 4 goes up, so we can actually get 448.55. Okay, so that is how much you can get due to what notes they've got, and this is how much it's going to cost him in pounds. All right, moving on then. Okay, ratio. So sharing in a ratio. This isn't all this stuff now will be non-calculated. Okay, so sharing in a ratio. Share £45 in the ratio 2 to 3. Okay, so this person's getting 2 parts of it. This person's getting 3 parts of it. All right. When we've learned this, there's usually like 3 steps to we follow, or that's how I like to do it anyway. Okay, so step 1 is find the total ratio. Right, so the total ratio is just by adding your parts together. So if we're sharing 2 parts to one person, 3 parts to another, we're sharing 5 parts in total. Okay, then we want to work out what one share is. So to do that, you do the amount that you're sharing, which in this case is £45, divided by the total parts. And we've just worked out the total parts, so it's 5. Okay, so 45 divided by 5 is £9. So that means the one share of this money is £9. Well, the first person's getting 2 shares, so that's 2 lots of 9. The second person's getting 3 shares, so that's 3 lots of 9. And you work those answers out then. Okay, so 2 times by 9 is 18. 3 times by 9 is 27. All right, and then always make sure that you check that answer then by adding the 2 numbers up. Okay, because we only had £45 to share in the first place. So when we add these 2 answers together now, if it gives us £45, then you know we've done it right. And if it doesn't give us £45, then we must have made a mistake somewhere. That does give you £45 if you add those together. Do the column method if you need to. So that's right, which means these 2 are right. And we move on. So still the same thing. Nick, Peter and Dave share £56 in the ratio 1, 2 and 4. Okay, calculate how much money Dave gets. So still the same sort of thing. Yeah, it's 3 people this time. So there's 3 different ratios, 3 different parts. All right, but we still do the same thing. So total ratio first, 1 plus 2 plus 4. Okay, so that gives us 7. So we're sharing 7 parts in total. So then we work out what one share is. So £56 divided by 7 is 8. So one share is 8. All right. And then this time it says calculate how much money Dave gets. So we don't need to do the whole thing really. If you look at the order in the question, Nick's name comes first. So Nick is the 1. Peter's name comes second. So Peter is the 2. And Dave's name comes third. So Dave is the 4. Okay. So by working that out, we can see that Dave gets 4 parts of the ratio. Okay, 4 parts of what's being shared. So in that case, Dave gets 4 lots of 8. Which is 32 pounds. Okay, so read the question because it's not asking us to work out all 3 of them there. It's just saying calculate how much money Dave gets. But we use the same method. Okay, moving on then. So still ratio, but this is where one part is given and we work out what the other part would be. So a bag contains red and blue discs, okay, in the ratio 2 to 3 respectively. So that's similar to the last question, 2 to 3 respectively, just means in that order. Okay, so I'm just going to write the ratio out first. Red comes first, blue comes second, the number 2 comes first, the number 3 comes second. So there's 2 red to every 3 blue. All right, then it says if the bag contains 18 blue discs, how many red discs will it contain? So once you've written the ratio out, I'm telling you in this question that there's 18 blue discs. So this 18 goes on the blue side here, all right? And it's similar to an equivalent fraction then. The 3 is being times by something to make 18, which in this case is 6. Okay, 3 times 6 is 18. So if this side of the ratio is times by 6, this side would be times by 6 also. So that would be 12. Okay, so there would be 12 red discs. So as long as you can set it out in a ratio like that and get the order of them correct, then that's an easy question in my opinion. Right, moving on then. So Jim, Ben and Di share sweets in the ratio 2, 5, 7. If Ben gets 20 sweets, how many sweets do they have altogether? So still the same order again. Yeah, Jim's name comes first, then Ben, then Di. Okay, so Jim is the 2, Ben's the 5, Di's the 7. So this time it says Ben gets 20 sweets. So Ben's in the middle here, look, that is changing to 20. And then that means that whatever the 5 has been multiplied by to make 20, the other 2 have to be done by the same amount. So it's obviously times by 4, isn't it? 5 times 4 is 20. So we have to times the other 2 numbers by 4 as well. All right, so Jim will get 8, and then Di will get 28. And lots of people would probably stop there and read the question carefully because we've done all the hard work. Don't lose a mark now for not reading it properly. It says how many sweets do they have altogether. So we can see how many they've had each. So altogether, it's just adding those values together. And so 8 plus 20 plus 28. Use the column method if you need to. All right, should be 56 sweets. 20 plus 20, 8 plus 8. Job done. Moving on. Okay, simplifying a ratio. So write 24 to 16 as a ratio in its lowest terms. So similar to simplifying a fraction, we divide the top and bottom by the same number until we've made them as small as possible. It's done the similar way in a ratio, only left and right. Okay, so I'm going to start with 24 to 16. If we want to do this as quick as possible, we're looking for the biggest number that will go into 24 and also go into 16. If you don't spot the biggest number straight away, it's no big deal. Just use any number to start with if you want, just to make it a little bit smaller, okay? As long as we all get to the same final answer at the end. So for this one, the biggest number that would work would be to divide by 4. Okay, so if we divide, oh no, that's wrong, sorry. The biggest number would be to divide by 8. But I'll do divide by 4 again in a minute just to show you we'd still get to the same answer. So if we divide by 8 for both of these, okay, because 24 is in the 8 times table, it's 3 times, isn't it? And 8 goes into 16 twice. So that's our final answer then. We can't simplify 3 to 2 anymore. I'm just going to do the same thing here now because I said about divided by 4 first of all, didn't I? So if we divide by 4, all right, we would get 4 goes into 24 6 times and 4 goes into 16 4 times. So you should be able to spot now, shouldn't you? If you've done that to start with, the 6 to 4 can be simplified again. They're both even numbers, so you can divide them both by 2, and that would still give you the same answer as we got here. Right? So there's no big deal if you don't always use the biggest number possible, but that's the best and quickest way of answering the question. All right. This one now, so write the ratio 15 seconds to 1 minute in its simplest form. So this time the units are different. All right, so we can't just simplify the numbers. We can't just start thinking, oh, what can I divide 15 and 1 by? Because we can only simplify a ratio if the units are the same. All right, so we either need to change them both into minutes or both into seconds. In this question, obviously, it would be much easier to change them into seconds. Okay, so I'm going to keep the 15 seconds as they are. And we all know the 1 minute is 60 seconds, or I hope we do anyway. So instead of writing 1 minute, we write 60 seconds. Now we can do the simplify. Okay, so biggest number possible that goes into both of those. Most people would try 5 first of all, and that's fine if you want to do that first, but the biggest number is 15. 15 goes into both. Okay, so if we divide by 15, that would be 1 second to 4 seconds. All right, but if you divide it by 5 first, then you would have got 3 to 12, and then you can divide 3 and 12 by 3, you would still get 1 to 4, hopefully. Okay, so that is that one. And then, yeah, I'll just do the next simplifying ratio one as well, and then stop there for this video. So there were 12 girls and 30 boys that belonged to a rowing club. Write down the ratio of girls to boys in the simplest form. Okay, so don't overcomplicate this question. It's not written in a ratio to start with, but we just write it in a ratio. So it says 12 girls and 30 boys. So girls comes first, boys come second. There are 12 girls, and there are 30 boys. So write the question as a ratio because it's not given to you already, and then just simplify. Okay, so we're looking for the biggest number possible that we can divide 12 and 30 by. We can definitely divide by 3. Okay, so how many 3s go into 12 is 4. How many 3s go into 30 is 10. Okay, and that should not be our final answer. Right, they're both even numbers. We can divide by 2. So how many 2s in 4 is 2. How many 2s in 10 is 5. And if you wanted to do that one in one step, to go from here to here in one step, that should be divide. All right, if you wanted to do that in one step, then we could have divided by 6 straight away. But as I've said, we get the same answer either way anyway, don't we? So you do whatever number you swap to be. So on to section 8 now, negative numbers. All right, so first one, put the following numbers in ascending order. So first of all, we need to understand what ascending means. It's usually going to say ascending or descending. Okay, so ascending means going up. All right, so this means smallest to biggest. Yeah, so ascending means going up, and descending means going down. So obviously that would be biggest to smallest. All right, so put them in ascending order. So first of all, the smallest one on here. If you need to draw a number line, then please do to help you. Okay, I'll do one just to show you. I won't do every single one, but let's say 0 is in the middle here. This was -5. This was 5. Okay, so -8 is the smallest number there, isn't it? Because -8 would be down here somewhere on the number line. Yeah, so -8 is the smallest one. Then the next smallest, so we imagine where -8 is on that number line, we're going to be moving up now towards 0. So the next number is -4. That's the next smallest number, isn't it? -4. Okay. And the next one would be -1, because don't forget -4 would be there, wouldn't it? -1 would be there. The next one then would be 0, because that's there. And the next one would be 7. That's up here somewhere. Okay, so -8 is the smallest number. Think of temperature if you need to. -8 would be the coldest temperature, and 7 would be the hottest or warmest temperature. Okay, so ascending order, smallest to biggest. Next one then, the temperature at 3 AM in a park was -5 degrees. By midday, it had risen by 12 degrees. What was the temperature at midday? So we just need to realize when something rises, it goes up, doesn't it? Okay. Yeah, so when something rises, it goes up. Okay, so it was -5 and it's going up, so it's increasing, you're adding 12. Okay, and again, use a number line if you need to. I'll do the same number line. All right, we're starting down here on -5. Yeah, this is 0, this is 5. So whenever we use a number line, adding is always moving in this direction. Okay, so if you need to do this, then start on -5 here and just move forward 12 times. So that would be -4, -3, -2, -1, 0. Okay, so that would be 1, 2, 3, 4, 5. So if we have a look, that's 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 2 more would obviously be 6 and 7. So the answer is 7. So the temperature at midday was 7 degrees Celsius. Okay, so just remembering that for that question, you're starting on -5 and you're going up by 12. So that means you're adding. So you're moving to the right on the number line. Okay, next one. One day in Newport, the temperature was 17 degrees. At the South Pole, the temperature was -45 degrees. What is the difference between these two temperatures? Okay, so the difference technically means subtracting them. All right, so how many more do you need to go from -45 up to 17? So the best way that I would do this is imagining a number line again. Okay, we're working out how to go from -45 all the way up to 17 on a number line or on a thermometer, whatever you want to say. So think about it logically. If you're on -45 already and you want to get up to 0, then you definitely need to go up by 45, don't you? If you're starting on -45 and you're trying to get to 0, that's adding 45, okay? And then to go from 0 to 17 is adding another 17, yeah? If you break it down logically. So in total, you've gone up by 45, then you've gone up by another 17, yeah, so add those together, you've gone up by 62 in total, yeah, 45 plus 10 is 55, plus another 7, 62. So the difference between the two temperatures is 62. Okay, adding and subtracting negative numbers then. So with this one, there's a little table that I always write down, and I get people to copy this down. Unfortunately, these are now the topics that you've been doing at home whilst you've been off, so we haven't actually covered these in lessons yet. Okay, so when we're adding or subtracting negative numbers, this table, okay, if the symbols are next to each other, then 2 pluses make a plus, 2 minuses make a plus, plus and a minus is a minus, minus and a plus is a minus. The best way to remember it is if the symbols are the same, it's going to be positive. If the symbols are different, it's going to be a negative. Okay, but these rules only apply to adding and subtracting when the symbols are next to each other. So if we have a look at the first one, okay, it says 8 plus -3. So that plus and the minus in the middle, they're next to each other with no symbols in between, okay, no numbers in between, sorry. So we can apply that to this table. So it's a plus and a minus together. If we look at this table, plus and a minus gives you a minus. Okay, so 8 plus -3 is actually just 8 minus 3, which is 5. And that's it. Okay, for question B, all right, it says 5 minus -6. So circle the two symbols that are next to each other. Okay, look at the table. So a minus and a minus gives you a plus. So 5 minus -6 is actually 5 plus 6, which is 11. Easy. Right, question C then, if you look at the question, it just says -7 plus 3. So this time the minus and the plus are not next to each other. There's a number in between. So the rules in this table don't apply to question C. Okay, so this is where we just imagine a number line. So if you're on -7 and you add 3, that means you move forward by 3. So you get 3 closer to 0. All right, so -7 plus 3 should just be -4. Right, if you're on -7 on the number line and you move forward 3 times, you'll get to -4. Okay, and then question D, if we have a look at it, it's -5 plus -2. So we do have two symbols next to each other. All right, and we've already covered this one. The symbols are different, so it's going to be a minus, isn't it? So really, what that one is -5 minus 2, because that plus and minus together gives you a minus. So this time, imagine a number line. Okay, you're starting on -5 and you're subtracting 2, so you're moving backwards by 2. So you would end up on -7. All right, so take your time with those questions. Read them carefully and figure out whether the symbols are next to each other. If they are, you can apply the rules. If not, then just think of using a number line to help you. All right, multiplying and dividing negative numbers then, the same rules apply in terms of what you're doing. So if the symbols are the same, it's always going to be a positive. If the symbols are different, it's always going to be a negative. Okay, and what I tend to say for this one is just look at the numbers first and work the answer out, and then all you've got to do is decide whether that answer is positive or whether it's negative. Okay, so for question A, we should all know that 8 times 2 is 16. Okay, then just look at the symbols that we're using. So the 8 is a positive and the 2 is a negative. So we're using a positive and a negative together. So the answer has to be a negative. Okay, for question B, right, just do the numbers first. So ignore the signs to start with. 3 times 9 is 27. Then we just need to decide whether that 27 stays as it is, making it positive, or whether it's negative. Well, in this one, we've got a minus times by a minus. So 2 signs are the same. 2 minuses make a plus. So the answer is 27. Obviously, there's no need for us to write a plus in front of it because we know that 27 is positive because there's no symbol there. Okay, so for question C, same thing, ignore the symbols, just do the calculation first. So 18 divided by 3 is 6, then look at the symbols. So this one was a minus. This one is clearly a positive because there's no symbol in front of it. So a minus and a plus together gives you a minus. And then question D, just do the calculation first. So 64 divided by 8 is 8, because 8 times 8 is 64. And this time, this one was a minus, this one was a minus. 2 minuses make a plus. So the answer is just 8. All right. So you do have to take your time with those types of questions. Adding and subtracting, for the rules to apply, the symbols have to be next to each other. Okay, and then multiplying and dividing, you just look at what symbols you're using, whether they're next to each other or not. Okay, moving on then. So percentage of a quantity, so just working out a percentage. All right, we've done this plenty of times. So I'm not going to write down every single rule. We should know them anyway. Okay, so 50% we should know is just to divide by 2. Okay, or to half it. Sorry. So A, I'm going to write the workings out, but you're clever enough to work it out in your head anyway. So for question A, 50% means to divide by 2 or to half it. So 68 divided by 2 is 34. So 50% of 68 is 34. Okay. For question B then, right, it says 25% of 68. So 25% is divided by 4. Okay. Well, that's the same as dividing by 2 twice. So lots of people remember 50% is half and 25% is half again. Okay, so either do 68 divided by 4 or just half it twice, makes no difference. Good thing about this one in particular is we've already halved it in question A anyway. So if we just half this 34 now, then that gives us the same answer, doesn't it? Yeah, which is 17. Yeah, half of 34, 17, and that's it. And then for 75%, okay, we've learned before, to get 75, you do 50% plus 25%, because 50 plus 25 is 75. And we've already worked out in A and B, 50% was 34, 25% was 17. So if we add those together, get 11 there, carry the 1, 5 there. Okay, so 75% was 51. There's a couple of ways of doing 75%. Right, the most common way though is to do 50% plus 25, but you could do, if you wanted to, 25% and times it by 3, or you could do 25% and take it away from the 100%, but most people would do it that way anyway. All right, so that's how we do that. So moving on then, I'm not going to write every single one of these down, but 10% divide by 10. Okay, because remember, percent means out of 100, doesn't it? So the reason we divide by 10 for 10% is because there's 10 tens in 100. Okay, so for question D, 10% of 76 is 76 divided by 10. Okay, so 7.6. Then for 30%, a few different ways of doing it, but most people would do 3 lots of 10%, because we already know how to work out 10%. So if we can do 10% and times by 3, that gives you 30%. Okay, so 10% of 80 is 80 divided by 10, which is 8. Okay, so 30% is 8 times 3, which is 24. And then for question F, again, there's a few ways of doing it, but most people would do 15% by doing 10% and then 5% afterwards. Okay, so for question F, 10% is divided by 10, so 120 divided by 10 is 12. And then 5%, okay, use your common sense. If we know 10%, 5% is half of that amount, isn't it? So half of 10% would give you 5%. So in this case, half of 12 is 6. But then please don't forget then that you've still got to add those together, haven't you? Because the 10% plus the 5% gives you 15, which in this case gives you 18. Okay, so 15% of 120 is 18. And there's loads of different ways of doing those. All right, just remember those rules. Normal percentages. All right, 1%. Remember I said in the last video, to find 10%, we divide by 10. Okay, because there are 10 tens in 100. So there are 100 ones in 100. So to divide by 100 would give you 1%. Okay, so for question G, 1% is 800 divided by 100. So how many 100s are there in 800? Is 8. Job done. Right, for question H, 2%. Well, common sense, isn't it? If we know 1%, then 2% is just 2 lots of 1%. Okay, so for question H, I would do 1% first, which remember is divided by 100. So how many 100 and 600 is 6. So that means 2% must be double that amount. Yeah, so you can either double it, or what some people prefer to do is add them up. Makes no difference. 2% is 12, and we move on. Okay, and then 40%, well, we already did 30% earlier, which was 3 lots of 10. So 40%, 4 lots of 10. It's not the only way of doing it, but that's what I'm going to do. So 10% first, so 10% of 90. Remember, 10% is divided by 10, so 90 divided by 10 is 9. So 40% equals 9 times by 4, which is 36. We keep going. Right, so wordly question now. So Terry has £250 in a bank account. So I'm going to underline what's important. Okay, the account pays interest of 3% per year. Calculate how much money Terry has in his bank account after 1 year. So we need to remember that interest is, it means that it's an increase question. Okay, interest is money that's added on to your bank account. Okay, it's always a lot less than 3%, though. It's usually 0.something%, because banks don't want to give you free money. But in this case anyway, he's got £250 in the bank, and after 1 year, that will increase by 3%. Okay, and the question's asking us how much money will he have in the bank after 1 year. So all we're doing is we're going to increase £250 by 3%. Okay, so don't try and take any shortcuts for this one. Basically, we need to work out what 3% is first, and then increase means to add. We'll add it on afterwards. Okay, so 3% is going to be 1%. Okay, times by 3. So 1%, as we've already discussed, is divided by 100. So 250 divided by 100 is 2.5, or in this case, £2.50. Okay, so 3% is 3 lots of £2.50. So imagine you were adding 3 250s together. If you want to do it, that's £7.50 definitely. Okay, so that doesn't mean he's got £7.50 in his bank account. All right, interest is increase. It means is £250 that he had originally in the account has gone up, because that's what increase means, isn't it? It's gone up by £7.50. Okay, so after 1 year, he's got £257 and 50 pence, and that's it. All right, so don't try and take any shortcuts with it. You've just got to work out with that type of question, whether the question's talking about increase or whether it's talking about decrease. Work out what the percentage is first. So in this case, it was £7.50. Then either add it on or take it away afterwards, depending on if it's increase or decrease. Okay, which leads us into these questions. So increase £140 by 60%. Okay, so it's increase. that means it's going up. So we're adding, yeah? And all we've got to do this time is work out 60% and add it on to 140. So in my opinion, the best way to do 60% would be to do 50 and then 10, and we've already learned those two, haven't we? So 50% is divided by 2. So half of £140 would be £70, yeah? And 10%, and be careful if you're setting it out like this, because it's not 10% of 70 now, is it? It's always 10% of the number in the question. So 10% of 140 is 14, okay, which means 60% is 84, so £84. All right, make sure then you don't make sloppy mistakes and then just move on to the next question, because we haven't finished the question there. We worked out the 60% is £84, but we haven't increased by that amount yet. Okay, we've still got to do the increase part. So it was £140 to start with. We're increasing it by 84, so we're adding 84 on. So do the column method if you're unsure. Okay, 0 plus 4 is 4, 4 plus 8 is 12, so carry the 1, 1 plus the 1 is 2. So after the increase, it's £224. So make sure you don't forget about that last part. It's either adding or subtracting, depending if it's increase or decrease. Right, a table normally costs £680. Right, in a sale, the price is reduced by 15%. Calculate the sale price. So this time it doesn't actually say the words increase or decrease, but I've underlined the word reduced. Okay, the word sale, they all mean decrease. So if you were buying something in a sale, you're paying less than the original price. So really what this question is saying is decrease £680 by 15%. So as with the others, we've got to work out the percentage first. We've done 15% already. All right, so that's 10% plus 5%. 10%, remember, is divided by 10. So 680 divided by 10 is £68. Remember, 5% is half of 10%, so half of 68 is 34. So if we add those together, okay, 8 plus 4 is 12, carry the 1, 6 plus 3 plus another 1 is 10. Right, so 15% is £102. Remember, that's not your final answer, is it? We're decreasing it by that amount. So it was £680, it's going down by £102, so we take 102 away from 680. All right, if you're doing the column method, do it properly. You can't do 0 take away 2, so we have to borrow them. So 10 take away 2 is 8, 7 take away 0 is 7, 6 take away 1 is 5. So the sale price of the table is £578. All right, so work out the percentage. In this case, then decrease it, so take it away from the original because it says reduced. Okay, using a calculator then, and we've done a lesson on this as well. The best way for us to do this, I'm just going to get my calculator out again. Best way for us to do this, okay, is remember the word of means to times, and all we've got to do is change this into a decimal by dividing by 100. Okay, so to change a percentage to a decimal, you divide by 100. If we do that every time, we can just type it into the calculator. So for question A in the calculator, okay, 23 divided by 100 is 0.23. Of means times, and then 680. So if we type that in, that gives us the answer straight away. Like we could work out 23% without a calculator if we needed to, but this question is saying we can use a calculator, so why waste time? Yeah, so 0.23 times by 680 is 156.4 is what comes up in my calculator. And remember, we're talking about money, so it has to be 2 decimal places. That's £156.40. Same thing for question B then. We divide this by 100. This means times. Okay, so 78 divided by 100 is 0.78 times by 4,500. That's what we type in. So 0.78 times 4,500 equals 3,510. No units this time, that's just the answer. And even with this one, it's still exactly the same method. So we still divide this by 100, okay, to make it into a decimal. That still means times. And if you need to use your calculator for this part, okay, for the dividing by 100, then do it. So I'll write that out, okay? So I'm going to put into my calculator 7.5 divided by 100. Because as long as we get our decimal right, that's our multiplier. It's easy from there. So if you're unsure, then please type it in. Right, that is 0.075. Okay, so then we do 0.075 times by 90. 0.075 times by 90 is 6.75. Okay, so finding a percentage of a quantity using a calculator should be simple. Okay, moving on then, comparing fractions. So this says put the following fractions in order from smallest to biggest. All right, remember that could say ascending as well, or descending. You must show your method. So it's not about guessing which one's the biggest, okay? We can't compare these fractions unless we make the denominators the same first, okay? So we need to try and think of a number now that 10 and 5 and 3 all go into. And we'll just make 3 equivalent fractions, and then it's easier to compare them then, okay? So if you think of your 3, 5, and 10 times table, the smallest number that's going to work is going to be 30, okay? So we're going to make the denominator 30 on each of these 3 fractions, okay? So the first fraction, the denominator was 10. We've changed it into 30, which is by times in by 3. Yeah, because 10 times 3 is 30, isn't it? So equivalent fractions, whatever you do at the bottom, you do the same to the top. So the new top number, the new numerator should be 9, because that's 3 times 3, okay? Then for the second fraction, there was a 5 on the bottom. We've made it into 30 by times in by 6, because 5 times 6 is 30. So we have to times the numerator by 6 as well. Okay, 2 times 6 is 12. Then for the last one, okay, we've clearly times it by 10. 3 times by 10 gives you 30, doesn't it? So that means 1 times by 10 gives you 10. All right, so it's important you don't just change the bottom numbers and keep the top the same. It's an equivalent fraction. So whatever you've multiplied the denominator by to make 30, times the numerator by the same amount. Now it's obvious for us to see which one's the biggest, which one's the smallest, yeah? So 9 over 30 is the smallest one. But when we write the final answer now, okay, we're not going to write any of these 3 fractions that I've just written down out of 30. We've got to use the fractions that were given to us in the question to start with. So 9 over 30 is the smallest, but that was 3 over 10 to start with. Okay, so 3 over 10 goes first. Then after that, 10 over 30 is the next smallest, but that was 1 over 3 to start with. So we write 1 over 3 as our answer. And the biggest one then is 12 over 30, but that was 2 over 5 to start with. Okay, so that would be our final answer. And that'll work with however many fractions there are in the question. Just make sure that you don't try and guess what the biggest or smallest is. Okay, it's easy to tell once you've made the denominators the same. So make them the same first, and then once you've made them the same, you're only using those to identify what's the biggest or what's the smallest. Then when you write your final answer, make sure it's like this, where it's the original fractions that were given to you in the question. Okay, right, adding and subtracting fractions. Okay, so you'll notice on this first question, we've got 2 over 11 plus 5 over 11. Okay, so the first thing that we need to remember is denominators, or bottom numbers, whatever you want to call them, okay, must be the same. You can't add or subtract fractions unless the denominators are the same. Okay, and if they are the same, this is something that really winds me up when people do it. If they are the same, they stay the same. Okay, so when we do 2 over 11 plus 5 over 11, the answer is 7 over 11. Okay, so once the denominators are the same, all you do is either add or subtract the numerators, and then try and simplify if you can, but we can't simplify this one anyway. Okay, so you never ever add or subtract the bottom numbers. Okay, so you make them the same if they're not the same, and then they stay the same. An easy example that I usually give is if I've got a pizza and I cut it up into 11 slices, and I eat 2 slices, and then I eat another 5 slices, I've eaten 7 out of 11, haven't I? I haven't all of a sudden eaten 7 out of 22. I only had 11 slices to start with. Yeah, so you never ever add or subtract the denominators. All right, so that was an easy one. The denominators were the same already. In this question, I'm just going to rewrite it. Okay, so we've got 3 over 5 plus 1 over 10. So, as I said on the last slide, you can't add or subtract until the denominators are the same. Okay, so if they're not the same, all we do is make them the same. So we make an equivalent fraction, similar to how we did in comparing fractions in section 14. Yeah. So my advice is look at the bottom numbers and pick the biggest one first. So in this case, a 10 is the biggest denominator, and see whether the other one goes into 10, which in this case it does. So if it does, then that means that we make both of them 10. Okay. So, because some questions you can get away with only changing one of the fractions, in some you might have to change 2. But in this one, because 5 goes into 10, we can make the denominator into 10. Okay. So the denominator on the first fraction was 5. We've changed it into 10 by multiplying by 2. Yeah, 5 times 2 is 10. So if we times the 5 by 2 to make 10, we have to times the 3 by 2 to make 6. Okay, 3 over 5 is equivalent to 6 over 10. Right? The second fraction, the 10 on the bottom was already there, so we haven't actually changed anything in that fraction. So the numerator stays the same. Okay, and then once they're the same, they stay the same on the bottom. 6 plus 1 is 7. The answer is 7 over 10. All right, so it's important that if the denominators are not the same, you make them the same first by doing an equivalent fraction. An equivalent, remember, means the same, equal to. So whatever you times the bottom by, you times the top by the same number. All right, so this is one now where I'll rewrite it. With this one, we can't just multiply one of the fractions, because if we use the method I just spoke about, then 8 is the biggest bottom number, but 3 doesn't go into 8. Okay, so in this question, we're going to have to change both of the denominators. So we need to think of the smallest number that 8 and 3 both go into. Okay, in this case, I believe it's 24. If you're unsure, you can always times the two numbers together anyway. Okay, so take your time with the next part then. So the first fraction, okay, so the 5 over 8, we're changing it into something over 24. So 8 goes into 24 3 times. So we must have times this fraction by 3. Yeah, we times the 8 by 3 to make it 24. So if we're timesing the denominator, the 8 by 3, we have to times the numerator, the 5 by 3 as well. Okay, so 5 times by 3 is 15. Okay, so 5 over 8 is equivalent to 15 over 24. Then we look at the second fraction. So we're not timesing the second fraction by 3 as well. Okay, look at the denominator. It was a 3 to start with, and we've changed it into 24. Okay, 3 goes into 24 8 times. So times that fraction by 8. So if we're timesing the 3 by 8 on the bottom, we have to times the 1 by 8 on the top as well to give us 8. So 1 over 3 is equivalent to 8 over 24. Okay, denominators are the same now, which is what we wanted. So it stays the same. And we do 15 minus 8. Okay, 15 minus 8 is 7. The answer is 7 over 24, because we can't simplify. Right, moving on, multiplication of fractions, okay? Work out the following, simplify your answers where possible. So what we need to remember for this is when you multiply fractions, all you do is multiply top by the top, or numerator by numerator, whatever you want to call it, and then the bottom times by the bottom. So there's no need when we're multiplying fractions to make the denominators the same. That only applies for adding and subtracting. Okay, so for question A, it is literally 2 times 5 on the top, 3 times 8 on the bottom. So it's just your times tables. It's simple. 2 times 5 is 10, 3 times 8 is 24. All right, and it says it in the question, but even if it doesn't say it in the question, you always try and simplify. So that would not be your final answer for this question, because 10 and 24 are both even numbers, so you can half them both. So the simplified answer is 5 over 12. Okay, so same thing applies then for question B. It's going to be 1 times 3 on top, 4 times 5 on the bottom, just your times tables. In this case, you can't simplify. 1 times 3 is 3, 4 times 5 is 20. That's just the answer. Okay, and then question C, I'm going to write that again, but with a slight difference. So most people would get confused with this one, and they would do 3 times 2 and then 3 times 7, but that actually won't work. Okay, we can only use the rule of top times top, bottom times bottom if they're both fractions. So at the moment, the 3 is a whole number or an integer, and the 2/7 is a fraction. So all we've got to do for this one is, instead of writing 3, we're going to change it to 3/1. So if you ever want to change a whole number into a fraction, just write a 1 on the bottom. So this is the same as doing now, 3/1 times by 2/7. Now we can apply our rule that we've just been doing. So 3 times 2 on top, 1 times 7 on the bottom. The answer is 6/7. And it's that easy. Okay, so the bottom numbers don't need to be the same. All you do is times the top 2 times the bottom 2, see if you can simplify. All right, moving on to dividing it. So dividing fractions, we need to remember when we're dividing fractions the rule of keep, change, flip. All right, so again, no need for the denominators to be the same. We apply the rule keep, change, flip, and we work the answer out. All right, so for anyone that's forgotten, keep, change, flip means you keep the first fraction the same. So in question A, the 1/5 is going to stay as 1/5. The change means you change the divide into the opposite, which is times, and flip means you flip the second fraction over. And this is the part that a lot of people forget about. Okay, so the second fraction then, instead of 2/3, is going to be 3/2. Okay, and once you've done keep, change, flip, it's just the same as what we looked at in section 16, multiplying. All you do is times the top 2 together and times the bottom 2 together. Okay, so 1 times 3 is 3, 5 times 2 is 10. The answer is 3/10. All right, so question B, same sort of thing again, but it's a whole number this time. So like we did in the last section, change the whole number into a fraction. So this will be 3/8 divided by 4/1. Okay, then we do keep, change, flip. So 3/8 stays the same. The divide changes to times, and 4/1 becomes 1/4. Okay, so flip it over. Then we do your multiplying. So 3 times 1 is 3. 8 times 4 is 32. That's the answer. You can't simplify. And then last one, so 2/7 divided by 3/4. Keep, change, flip. Keep the first fraction the same. Change the divide into times. Flip the second one over. So instead of 3/4, it's 4/3. Okay, then do the multiplying. 2 times 4 is 8. 7 times 3 is 21. Can't simplify, that's your answer. Okay, so adding and subtracting, make the bottom numbers the same. Multiplying, times the numerators, times the denominators. Dividing, keep, change, flip. Moving on then, so the last few sections now are all to do with mixed numbers. So first of all, converting improper fractions and mixed numbers. Okay, so the question says convert the following improper fractions into a mixed number. So they're improper at the moment because the top is bigger than the bottom. Sometimes they're called top heavy. Okay, so when we change it into a mixed number, all that means is it's going to be a whole number and then a fraction left over. Okay, so if you can remember, which we've discussed before already, that this fraction line means divide. Okay, all we're doing is dividing 10 by 3. So we need to see how many whole 3's go into 10 for this first question. So if you counted up in your 3 times table, the closest you would get to 10 would be 9, wouldn't it? Without going above it. And that's 3 times. 3 goes into 9 3 times. Okay, so we can get 3 whole 3's into 10 with a remainder of 1 left over. So it's 3 and 1/3, 3 and 1/3. Okay, 3 times 3 is 9, plus another 1 is 10. So you're dividing every time. So for question B, we're dividing 15 by 4. So we're working out how many whole 4's go into 15, which in this case would be 3. Okay, because 3 times 4 is 12. All right, we didn't want 12, we wanted 15, plus a remainder of 3. And then same thing for the last one, how many whole 9's go into 20? So if you think of your 9 times table, closest you'll get is 2 times 9, which is 18. Okay, so 18 means there has to be a remainder of 2 left over. Right, so don't overcomplicate it. It's how many whole times the bottom goes into the top, and you write the remainder as a fraction. Okay, so the other way around now, mix numbers into improper fractions. This part now, all right, the bottom number, the denominator, is always going to be the same. So whatever it is in the question, it's going to stay the same in the answer. So I'm just going to write that out straight away. Okay, so as an improper fraction, question D is going to be something over 2. All right. So remember, the big number now is how many whole times it goes into it, because we're talking about 2's in this case. This big number 2 here means we've got 2 whole sets of 2 already. Okay, so the way we work this out is you do the big number times by the bottom and then add on the top. So we've got 2 whole sets of 2, which is 4, and then we've got 1 extra 2 as well, which is 5. So 2 times 2 is 4, plus 1 is 5. So it works the same way every single time. So with this one, it's going to be 4 times by 5 plus 3, because the 4 means we've got 4 whole sets of 5, so that's 20, plus another 3, that's 23. And then for question F, we've got 6 whole sets of 8, so that's 6 times 8, and then plus another 5 added on it after. All right, so 6 8s is 48, 48 plus 5, 53. Okay. And those skills are important for the next section now, which I'm going to have to do on a separate video, and that's adding, subtracting, multiplying, and dividing with any mixed numbers as well. Okay, we need to be able to definitely convert from mixed to improper and improper to mixed. We'll keep going. So adding and subtracting mixed numbers. Okay, so when we do this, there are 3 steps we need to follow every single time. So step 1 is convert into improper fractions, which we just covered at the end of the last video. So convert to improper fractions first. Then, in this case, we're going to add, okay, but it could be subtract, or multiply, or divide. Okay, and we've learned all 4 of those things in the last video as well. And once we've done that, then from the improper fractions, if possible, you convert back into a mixed number for your answer. Okay, only where possible, which I'll discuss as we go through. Okay, so all three of those steps we know how to do individually. It's just putting them all together in one question. Okay, so 2 and 1 over 3. Okay, remember the denominator stays the same, and to convert that into an improper fraction, the 2 means we've got 2 whole sets of 3. So we times, and then we add the top one. So 2 times 3 is 6, and then plus 1 is 7. So 2 and 1/3 is 7 over 3. Then we do the same thing with the second mixed number as well. So we got 1 whole set of 4 plus another 3 on top. 1 times 4 is 4 plus 3 is 7. All right? So 7 over 3 plus 7 over 4. But thinking back to what we've done now, adding and subtracting, the denominators have to be the same. So we can't just try and add those together now. Make the denominators the same first. Okay, so the smallest number, the 3 and 4 will both go into is 12. So we're going to make both of these denominators into 12. Okay, so 7 over 3, we clearly times that one by 4, yeah, because 3 times 4 is 12, isn't it? So times the top by 4 as well. 7 times 4 is 28. Then for the second fraction, there was a 4 on the bottom, so we've had to times that by 3 to make it 12. So we have to times the top by 3 as well. 7 times 3 is 21. Now the denominators are the same, stays the same for the answer, and we add or subtract, but add in this case, we add the numerators together. So 28 plus 21 is 49. Okay, and I said earlier on then, the third step is to convert back into a mixed number if possible. So it is possible to do this as a mixed number because at the moment it's an improper fraction, isn't it? So if the top is bigger than the bottom, you can convert it back into a mixed number. So 49 over 12 as a mixed number is how many whole 12s will go into 49, and then the remainder as a fraction. If you think of your 4 times table, okay, then 4 times 12 is 48. So the answer is 4 and 1 over 12. Okay, take your time with that type of question though, because they are quite tricky, but follow those steps. Like I've already said, we can do all 3 of those steps individually. It's just putting them all together in one question. So 4 and 1 over 12 for that one. So next one, this time is subtract, but all the steps that we follow are exactly the same. Okay, so this is something over 2 and something over 5. as improper fractions. Okay, so we got 3 whole sets of 2 plus another 1, so 3 times 2 is 6, plus 1 is 7. And in this one, we've got 1 whole set of 5 plus another 3, so 1 times 5 is 5, plus 3 is 8. Okay, and exactly the same thing as last time. Now the denominators are not the same, so we can't subtract them until we make them the same. Okay, the smallest number to use in this case, excuse me, the smallest number to use in this case is 10. All right, so the denominator has changed from 2 to 10 by times it by 5, so we must be doing the same on the top. Yeah, so 7 times 5 is 35. And on this one, the denominator was 5, we've times it by 2, because 5 times 2 is 10, isn't it? So times the top by 2 as well. And then this time, I know it sounds obvious, but it's surprising how many people do it. We're subtracting. So it's 35, take away 16, not 35 plus 16. Okay? So do the column method if you need to. 35 take away 16 is 19, I believe. Okay? So 19 over 10, can we change that into a mixed number? Yes, because the top is bigger than the bottom. So how many whole tens will go into 19 is 1, with 9 over 10 left over. Job done. Keep going then. So multiplying and dividing is the last section now. All right, so the only difference now is the middle step. So when we were adding and subtracting in the last section, we have to make the bottoms the same. In this case, the question says times, so we're going to times. So step 1 is still to change them as into improper fractions. So we'll do that first. So something over 2, and something over 3. So we've got 3 whole sets of 2 here, plus another 1. So 3 times 2 is 6, plus 1 is 7. We've got 2 whole sets of 3 here, plus 2. So 2 times 3 is 6, plus 2 is 8. All right. This time we're multiplying them together, so we don't have to make the bottoms the same. Remember, we just times the top 2 and times the bottom 2. So 7 times 8 on top, 2 times 3 on the bottom, so 7 eighths, 56. 2 times 3 is 6, and then as a mixed number, it'll work because the top's bigger than the bottom. So how many whole 6s go into 56? Then you write your remainder as a fraction. So if you're thinking of 6 times table, okay, you can get 9 whole 6s, 56, because 9 times by 6 is 54, yeah? So there's a remainder of 2 left over. But this is the first time this has happened then in the questions we've been doing. You wouldn't leave the answer as 9 and 2 over 6, okay? Because the 9 is going to stay the same, all right? But 2 over 6 can be simplified to 1 over 3. So just be careful with the fraction part of your mixed number. If that can be simplified, then you have to make sure you do so. All right, so change them to improper fractions. In this case, times them together, change it back to a mixed number afterwards. So on to dividing then. Steps 1 and 3 are still the same, so we're still going to change to improper fractions. We're still going to change the final answer back to a mixed number if we need to. This time it says divide though. Remember, divide is keep, change, flip. So 1 and 2/3, okay, or 1 and 2 over 3 means we got 1 whole set of 3, and then another 2 added on afterwards. So 1 times 3 is 3, plus 2 is 5. And don't get confused by the next part, okay? The next part is just a normal fraction. 1 over 5 just stays as 1 over 5, isn't it? So you can only change it to an improper fraction if it's a mixed number to start with. 1 over 5 is not a mixed number. All right, so it's 5 over 3 divided by 1 over 5. Now we do keep, change, flip. So keep the 5 over 3 the same, change the divide to multiply, and then flip the second fraction over. So instead of 1 over 5, it's 5 over 1. And now that is the same as the last question, isn't it? Now it's times in, so we times the top 2 together, times the bottom 2 together. So 5 times 5 for your numerator, 3 times 1 for your denominator. So that is 25 over 3. And then as a mixed number, how many whole 3's go into 25 is 8. 8 times 3 is 24, with a remainder of 1 left over. Okay, so 8 and 1 over 3. All right, I believe the next one's the last question, right? Yeah, okay, so same thing. Improper fractions first. So this, oh my bad. What's going on there? Let's go back. Okay, correct. Right, so evaluate the following, giving you answers, mixed number, blah, blah, blah. So something over 2 for the first one, divided by something over 7. Okay, so 3 whole sets of 2, plus 1, 3 times 2 is 6, plus 1 is 7, 1 whole set of 7, plus 1, 1 times 7 is 7, plus 1 is 8. Okay, so we get 7 over 2 divided by 8 over 7. Keep change flip next because it's divide, look, so keep the first one the same, change the divide to times, flip the second fraction over. Now we're multiplying, so top 2 together, 7 times 7 to the numerator, 2 times 8 to the denominator, so 7 sevens are 49, 2 times 8 is 16. Okay, we can still do that as a mixed number now because 16 does go into 49. Slightly harder this time, yeah. If you don't know your 16 times table, then just write them down the side of your page, it's no big deal. Okay, so 16 will go into 49 3 times, I believe. 3 times 16 is 48, so that's 1 over 16 left over. Okay, and that's it. So hopefully you find these videos helpful, so you can check how you've been doing with your revision, and hopefully we'll see you soon. Enjoy your Christmas.